All right, ladies and gentlemen, welcome back. Mr. Hipley and I have been deep in thought here. We were trying to figure out what variable we thought might be able to affect the speed of our marble. Okay, in our deep intellectual thinking that scientists do, we realized that we had a marble that was made out of glass. Okay, that glass marble had a smooth finish on it. Okay, and we also have a bunch of other marbles. So we looked at some of the other marbles and we saw that there are some marbles that don't have a smooth finish. They actually have a rough finish.
See these little red marks on here? They're kind of bumpy like sandpaper. This one has like green bumps on it. So they're not as smooth as our control, which was like glass, really smooth.
So our control, right, is our baseline. Now we are going to run a test to see if that finish, okay, on the marble, so the marble size is exactly the same. We're using the same ramp setup. Our peg is still 2 pegs up, and we're still measuring 2 meters from the bottom of the ramp down, and we're going to see, can we get our roller coaster cart to go any faster? So we're going to test, okay, does a rough marble travel faster than a smooth marble? So right now what you guys should do with the video is hit pause, okay, go to your lab sheet. On your lab sheet, you guys will see on the data table that there is a place for you to create a hypothesis. Okay, your hypothesis is going to be an if then because statement. So you want to say if the finish on the marble is rough rather than smooth, the marble will go, do you think it's going to go faster? Do you think it's going to go slower? Do you think it's going to not affect the speed of the marble? And then give us a because. Why do you think that? What gives you that idea? Why would you think it would go faster? Why do you think it would go slower? And you want to think about what you might know about science in that because. Okay, do you know anything about motion that might give you an idea as to why that would go faster, slower, or stay the same speed? Okay, so hit pause right now. Okay, complete that hypothesis. Once you have your hypothesis written, come back. Okay, and we'll run through test number 1, see if we can get our marble going any faster. All right, let's do it. Okay, Mr. Hipley. So you now should have a hypothesis written. If you don't, again, pause, go to the data table, write your hypothesis, then come back and watch the rest of the video. We're now gonna do test number 1 to see, does the finish on the marble affect how fast the marble will go? And we're looking at a rough marble now instead of a smooth one. All right, let's see what we get.
Okay, here goes our test with the rough marble. Okay, so ready, set, go.
We might have to redo that one. I think it went off the table just before it hit the end point. So we're gonna try it one more time.
All right, here we are.
Okay,
you
ready?
Stopwatch clear?
Yep, I'm ready.
On your mark, get set, go.
Okay, people. The marble traveled, the time it took to go the 2 meters was 1.13 seconds. 1.13 seconds. Okay, if we compare that to the first trial for the control was 0.02 seconds. Okay, so it looks like it took a little longer for the rough marble to travel. Let's see what our other 2 trials come up with. Thank you.
Stopwatch clear.
All clear, all clear.
On your mark, get set, go.
All right, we are looking at a time of 1.17 seconds. 1.17 seconds.
There we are.
Okay, and our final trial, let's see if we can get a good piece of data here.
Okay, on your mark, get set, go.
Ooh, that time it was fast. Okay, I got 1.05 seconds. I think maybe we should retry that because maybe Mrs. Ulmer's timing wasn't as fantastic as I think. Okay, so we're gonna redo that one, see if we get a number that's like that again, or if we happen to get one that's closer to the first two.
Right,
so maybe that was an outlier because of probably human Mrs. Ulmer error.
Okay, stopwatch clear.
Clear.
On your mark, get set, go.
Okay, so for this one, okay, I am gonna get rid of that 1.05. Okay, because I think that was probably me just being super excited about the timer. Okay, this time I got 1.11 seconds. 1.11 seconds. So that was the third trial for our first test. Now that we have the 3 trials done for both the control and for test 1, okay, we are going to calculate the mean time or the average time. Okay, you probably all remember this because you spent a lot of time over the summer thinking about means and averages. So I'm sure you remember that to find the mean or the average, you're going to take the numbers, add them together. Not all 6 of these numbers, I'm just adding up. Okay, T1, trial 1, 1.02. Then I'm adding 1.09, and then I'm adding 1.08. I total those numbers together, so put those in your calculator. Once you add them up, then you divide by 3. If you put it in your calculator or if you put it in the computer as 1.02, 1.09 plus 1.09 plus 1.08 divided by 3, you run into a PEMDAS mistake. Okay, so if you remember PEMDAS from your math classes, parentheses, exponents, multiplication, division, okay, and then addition and subtraction. Okay, well, if we put them all in the same line with no parentheses, it's gonna divide before it adds. Okay, so you've gotta put the addition part in parentheses or just do it separately. Okay, so add up your 3 numbers. Once you have them added up, divide by 3, and that will give you your mean time for the control. Okay, that mean time for your control. Okay, then we have to calculate the speed from that. And remember, speed is distance over time. So the distance traveled by our marble was 2 meters. That was the distance we chose. And then you take that distance divided by time. Okay, once you've done those steps, and maybe I went too fast and you can rewind and look at that again. Once you've done that for the control, then you'll go back and redo it for the test. Okay, same process. So for the test, I'm gonna take 1.13 plus 1.75 plus 1.11. Oh, sorry, this isn't a 5, that's an S. So 1.13 plus 1.17 plus 1.11. You'll add those 3 numbers together, then divide that total by 3. And once you have that total divided by 3, that is your mean or your average time. Hopefully you remember why we're dividing by 3. We're dividing by 3 because we have 3 pieces of data or 3 trials. So you always divide by however many trials or however many pieces of data you have. Okay, so we have 3 for our control, 3 for our test. Once you've calculated the mean time, record that on your data table. Okay, once you have it recorded on your data table, then you're gonna calculate, okay, from there, calculate the speed. Okay, so speed equals the distance, ours was 2, okay, 2 meters that the marble traveled, divided by that mean time. Okay, so distance divided by time tells us the speed of the marble. Okay, and then we'll be able to compare the control speed to the test speed and find out, okay, was that smooth marble or was the rough marble? Okay, which one was actually faster? Okay, Mr. Hipley is working on his calculations right now. Okay, he's an outstanding mathematician, which is why I left him to do that job so there'd be no mistakes. Okay, so he did the calculations. Okay, and maybe he has a speed, okay, for the first one.
I do. Okay, so
the second one you're on your own for.
Okay, so here's all the math that I did. So I took my 3 trials, I added up the times, right? I got a mean time of 3.19 seconds. I then took that, actually that wasn't my mean time, that was how I added up my 3 trials. I got a time of 3.19, and then I had to divide it by 3, right? Because I had 3 trials, and my mean time was 1.06 seconds, okay? So then I took that time to calculate speed. I'm going to use this equation, speed equals distance divided by time, okay? So remember we timed our marble for 2 meters, so the distance was 2 meters, and I divided by my mean time of 1.06, and it came up with a speed of 1.89 meters per second.
Okay, it's important you guys include those units on your answers. Okay, so it's in meters per second because the distance that was traveled was in meters, and how we measured the time was in seconds. Okay, you could have miles per hour, right? Those are other units that are used to measure speed, but we're scientists, so we don't like those kind of measurements. We use meters and seconds rather than miles, all right?
So this was the speed of our control, right?
Okay.
That was the yellow marble, the nice smooth one. Traveled a speed of 1.89 meters per second.
All right, it's up to you guys to calculate the speed of the test marble. Okay, so calculate that. Once you have that speed, you then are able to compare your control to your test. And after we complete the second test, you'll be able to do the analysis questions related to the lab using the speed that you calculated. All right, people, we'll come back here in a second with test number 2.